All right. So even though word problems tend to be things that students don't enjoy doing, I think that the systems of equations word problems are actually kind of fun. Excuse me, and it also makes math make sense a little bit more. So this is going to just be a little exploration of two problems. I actually just wrote these problems using accurate information as of May 14th, 2020. So these are the actual prices that I found. So anyway, I hope you like it. So in order to solve systems of equations word problems, you need to be able to turn written words into equations to then use. Um, so I'll show you how to do that, and then you're going to choose a method to solve. We've learned three methods to solve: graphing, elimination, and substitution. And you can find those in other videos. Then you will solve the resulting system and interpret what your answer means. So where in the other videos about graphing, elimination, and substitution, we just found an answer. They actually didn't mean anything. Now there's going to be some context to them. So you'll see these kinds of problems in science and all many other subjects. So for example number one, at Chick-fil-A, the cost of a chicken biscuit and a large iced tea is $4.78. The cost of two chicken biscuits and three large drinks is $11.65. What is the price of one chicken biscuit? Also, how much is one large drink? All right, so we're going to start by assigning variables, which I didn't really write up here, but I'm going to model down here. The first thing you need to do is assign variables. So I'm going to say, let B stand for a biscuit. And I'm going to let D stand for a large drink. Okay. And then we're going to use that to write equations. So let's write our system down here to begin, and then we will use this space over here to solve. So I'm going to highlight that first sentence. It says, the cost of a chicken biscuit and an iced tea is $4.78. Well, we are going to use substitution to say, okay, so a biscuit, B, and means plus, add, a drink, one drink, is equals $4.78. Okay? And now we have another sentence to do. So this is one equation. Let me highlight that yellow so that it matches the thing at the top. We also know the cost of two biscuits and three drinks is $11.65. So we're going to turn that into another equation. This time we have two biscuits, 2 times biscuit, and three drinks, 3 times drink, is equals $11.65. Okay? So that's an example of how you would turn the words into math, into equations. Now we need to decide the best way to solve this. You can choose graph, elimination, or substitution. For me, when I look at this, I would like to do the elimination style. I love the elimination style, but you really get to choose. But for me, I'm going to model elimination. So when we do elimination, what we do is we stack the problems. Okay? And then we see, can we just add them together and get rid of one of the variables? And the answer is no, we can't. We're going to have to do something. So what I'm going to do is I'm going to say, okay, I could multiply this whole top equation by -2. And I picked -2 because -2 times b is -2b. And I know that if I add -2 plus 2, I'm going to have 0 b's. And that's kind of what I'm going for. So I'm going to choose -2. Another good choice would have been -3, and then you would have canceled out your d's. So now I'm going to go down here because I ran out of space. -2b minus 2d equals, and we need to multiply 478 times 2. So I'm going to go to Desmos because, hey, why not? and do 478 times -2. -$9.56. Now we did not touch that second equation. It stayed the same. So I'm just going to write that here underneath. All right, and now for the elimination method, we add these two equations together. -2 plus 2 cancels. -2d plus 3d equals d. And I'm going to use the calculator even though I don't really need to. Oops. -$9.56 plus 11.65. D equals 209. All right. So now we know how much a drink costs. A drink costs $2.09. All right. But we need to also know how much does it cost for a biscuit. So we're going to choose one of our original equations. I'm going to choose the top one. And we're going to use the substitution property to substitute 209 for D. And everything else stays the same. Remember this from solving systems? All right, we have plus 209, so in order to solve, we need to subtract 209. So we have B equals 478 minus 209. That is 269. So we would, again, when you do systems, we write the answer as a coordinate. 269, 209. That's your biscuit and your drink. All right. Let B equal biscuit. So a biscuit is $2.69 and a drink is $2.09. And that's accurate for 2020 for Chick-fil-A. Many people prefer to use the graphing method for this kind of a thing. If you prefer graphing, you need to remember that you are not able to put B and D in. Instead, you do X and Y. So you would, in that case, have X for B and Y for D. So you would do X plus Y equals 478 as one equation. As your other equation, you would have 2x plus 3y equals 1165. And you might be asking yourself, why in the world did she do all that work when she could have just graphed it? But it's because it's good to practice the different strategies. You need them later on. And you may remember that when you have a system of equations, the solution is at the intersection point. And if you look at the intersection point, 269, 209, those are the prices that we got. All right, so you could do it that way also. Let's look at one more example. And this also is accurate as of right this moment. Okay, here we go. A large pizza from Manhattan Pizza in Warrenton costs $14.99 plus $2.49 per topping. Okay, so that's our first bit of information. A large pizza from Grioli's costs $2.50 plus $1.99 per topping. That's a big difference, right? And the question we want to answer is how many toppings need to be added to a pizza from Grioli's and Manhattan in order for them to cost the same? So step one, we need to write equations for each of these sentences. But first we need to assign variables. So I'm going to say let P equal pizza and let T equal topping. All right. All right, so let's write our equations. Our first equation, I wonder if I write with a yellow marker so it will show up. Our first equation is a pizza from Manhattan Pizza. So one pizza from Manhattan Pizza costs, that equals $14.99 plus $2.49 per topping, and we're using T for topping. That equation should look familiar, that format of an equation. We may need to use a commutative property to switch those around in your head, but this format should be familiar. All right, let's look at the second sentence. A large pizza from Grioli's costs $12.50 plus $1.99 per topping. All right. Now for me, I look at this and I'm like, these are already perfect to graph. Okay. I wouldn't bother going through any of these methods. I may use the substitution method, but I would probably immediately go to graphing. For right now, for us, I'm going to model the substitution method just for review, and I'll also show you how to graph it. All right. If we choose to use the substitution method, these are already solved for p. So we can use substitution to substitute an entire expression into the other one. So where we see this p, we could actually type or write this. So I'm going to do $14.99 plus $2.49t equals $12.50 plus $1.99t. All right, so we just substituted in using the transitive property. This equals p and this equals p. So these must equal each other. All right, using the steps to solve an equation, we're going to solve this equation. I'm going to subtract $12.50 from both sides. I don't know why. Remember, there's 4 choices that you can choose. That's just what I chose. $14.99 minus $12.50 would be $2.49 plus $2.49t equals $1.99t. We need to get all of our t's to the same side. So we're going to subtract $2.49t and move it over here. So we have $2.49 equals, let's see, $1.99 minus $2.49, negative 0.5t. And then we're going to divide by negative 0.5. So t equals $2.49 divided by negative 498. And we're going to have to think about what that means in a few minutes. But for now, we're going to use that and substitute it in. Although, now that I'm doing it, I feel like this isn't going to work out right. I don't know. We'll see. All right. So we need to substitute that into one of our original equations. 1250. So P equals 1250 plus 199 times negative 4.98. Okay. 199 times, so P equals 1250 minus 9.91, and then 1250 minus 9.91 is 259. All right, so to me it looks like about 2.5 pizzas would make them break even. But let's look, because my answer here doesn't make sense, and I don't like that. And this happens sometimes when you do math. You can kind of hear me hesitating as I do this video because something doesn't quite make sense to me about this problem. And remember, I wrote it. It should make sense, but something's off. So let's check it out in here. Y equals $14.99 plus $2.49 per topping. There we go. Also, one pizza, $12.50 plus $1.99 per topping. Yep, that's right. All right, so what we need to figure out now is how many toppings you need to add to a pizza for a pizza from Grioli's and Manhattan to cost the same. So this is kind of weird, I guess, because of we did it right. We did all the process right. I think it's because of the actual cost difference. It's a big cost difference. So what this is saying, we have on here pizza as Y and toppings as X. So in a weird way, what this graph is telling us is that the only way for these pizzas to cost the same exact amount is to have -5 toppings on a pizza. If we had -5 toppings on a large pizza, if that was possible, right? A large pizza from Manhattan and a large pizza from Grioli's, they would cost $2.59. Okay, that is weird. It doesn't make logical sense. I didn't pre-do this problem before I showed it to you, but wow, that's a big difference. I think that if the quality of the pizza is the same from Grioli's and Manhattan, I would absolutely choose Grioli's because it's so much cheaper. I hope I didn't confuse you too much by those numbers, but really you can see I kind of confused myself for a minute there um, because those numbers are way different from each other. Anyway, hopefully you learned something from that. But basically, the gist is write equations that make sense from the information you're given. Choose a method to solve. Obviously, graphing is the easiest method. Um, and then interpret your answers. And this problem made sense. It's $2.09 for a large drink and $2.69 for a chicken biscuit. But even though we did this one correctly, the answer doesn't make a lot of sense. We're not going to put -5 toppings on a pizza and then pay $2.59. So it's just a weird problem, but that's how math works. Sometimes it works beautifully and sometimes it's a mess, and we need to be able to interpret what that means. So unintentionally, I hope that was super valuable. Talk to you later.